Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is IGCSE Physics. It's paper 4. We call this subject theory. This is extended and extended paper, extended physics. The code for this subject is 0625. Today we have set our hearts to solve October-November 2023 4-2 paper. This paper 4 belongs from the zone 2. In this video, we are going to solve a single question, which is question number 3. This question is related with the impulse, momentum, resultant force, and why we are making this video? Because the topic momentum has been added into the Cambridge O-Levels physics syllabus, and because this is the new topic for the Cambridge O-Level students, we do not have that much questions in our past paper. So we are collecting these questions for our O-Level students from the IGCSE syllabus. So let's start this video. So let's go to the paper. Okay. So here we have that question. This is the question number 3 of that paper. So it says a balloon of mass 15 gram is glued to a straw. The straw is threaded onto a horizontal string as shown in the figure 3.1. The balloon is filled with air and then air is released. So when you will release the air, so because this is glued to this straw and this straw is on this string, so this balloon will move forward, the air will be exited from, it will exit from here, from the backside. So air will be going in this direction, balloon will be going in this direction. As the air leaves the balloon experiences a force. The balloon accelerates from rest until it reaches a constant speed. It then travels 0.67 meter in 0.18 second at this constant speed. Explain in word what is meant by the term impulse. The word impulse, this is basically the change in the momentum. The change in the momentum is called impulse. So there is another definition also. Impulse is also the product of the force and the time. Uh, they can two words. Impulse is change in momentum, and impulse is force multiply the time for which the force is acting on the body. So impulse is the product of force and time, or you can say impulse is the change in the momentum. Okay, so let's have force multiply time for which the force acts. Okay, so then we have the second part of the question number 3A. Second part, calculate the resultant impulse on the balloon while it is accelerating. So first of all, the impulse is equals to the change in the momentum. Initially, the balloon was at rest, so its momentum is 0. The final momentum of the balloon is, we know that it is given that okay, so the impulse is equals to the change in momentum. That is final momentum minus the initial momentum. Because initially it was at rest, so the initial momentum of the balloon is 0. So the final momentum is mv. Now the v is the velocity because the balloon is moving at a constant speed. So that speed will be distance divided by time. We can use this formula that in the place speed is equal to distance divided by time because the balloon is moving at constant speed. So that's why I'm using this formula. He moved at constant speed for 0.18 second and 0.67 meters he covered. So the distance traveled is d, which is 0.67 divided with the time, which is 0.18 second. Where the m is, it is given, the mass of the balloon is given. The mass of the balloon is 15 gram. But I will convert this into kg. So for that, I will divide it with 1000. So that's why this is the m, this is m, and this is distance divided by time. So 0.015 multiplies 0.67 divided by the time, and you will get 0.055505558, sorry, and that is 5.6 expo minus 2. 5.6 expo minus 2 Newton second. Force multiplied time, that's the unit of the Newton second. So Newton second, our answer is right. Hopefully you understand this. Okay. Now he says explain. Now the next question they are asking is the second part. The third part. Explain how momentum is conserved as the balloon accelerates. Initially, the momentum of the balloon is zero because the balloon was not moving. Then, when the air is exiting from it exits from the behind of the balloon, and the balloon moves forward. Now, the momentum of the balloon, which is moving forward, and the momentum of the air, which is going backward, they both will be equal, and the total momentum will be zero of the system. So the momentum of the balloon is equal in size to the momentum of the air, and the momentum is conserved as air released from balloon is in the opposite direction to the balloon. You see, the balloon is going to the right, but the air is going to the left. They both are going with the same momentum. So their resultant momentum will be zero. So this is how the momentum is conserved. Before that, the momentum was zero. When the air is released, the momentum of the whole system is still zero. So this is how momentum is conserved as air released from the balloon moves in the opposite direction to the balloon. Momentum of balloon and the straw is equal in size to the momentum of the air. So this is what the marking scheme is saying, and this is what we have written. This answer is written by one of my students. So okay, now question number this is question number 3, and it's B part. He says the figure 3.2 shows the direction of the two forces acting on a different balloon as it moves. So here we have one force which is to the right, which is of 0.40 Newton force, and here we have a downward force which is 0.74 Newton force, and both these forces are making 90-degree angle with each other. Determine the magnitude and direction of the resultant force on the balloon. It's a 4 marks question. We have to tell what's the magnitude. We have to tell what is the direction relative to the horizontal force. Okay. So if you want to add up two forces, we will do it graphically. So I'm going to choose a scale. For example, we choose that 1 centimeter will represent 0.1 Newton. So 0.4 force will be represented with the 4 centimeter, and 0.74 Newton force will be represented with 7.4 centimeters. So this is the scale which we have chosen. So we will draw these two forces. You can see I have drawn this force, this vector, which is of 4 centimeter, and perpendicular to this downward direction, we have drawn a line of 7.4 centimeter, which represents 0.74 Newton. The angle between these two forces is 90 degree. Now I will open my compass. This is very important how you complete the parallelogram. These two vectors which are to be added, I want to find out their resultant force. Their tails are joined together. So when the two vectors whose resultant force you want to find out, you have placed them such a way that the tails are joined together. So we use the parallelogram law. So in the parallelogram law, we complete the parallelogram. We suppose these are the adjacent sides of a parallelogram, and then we complete the parallelogram. So how you do this? You open your compass, 7.4 centimeter, take this point as the center, you draw this arc. So this is an arc of radius 7.4 centimeter, and you have taken this point as center. Then you open your compass 4 centimeter, you take this point as the center of the arc, and you draw this arc with a radius of 4 centimeter. Where these two arcs intersected each other, you join this point with this point, you join this point with this point, a perfect parallelogram will be automatically formed. Then where the tails of those two vectors which are to be added, their tails were put together, you join that point with the opposite corner of the parallelogram. So this is your resultant. So this is my resultant. With the help of the scale, measure this. When we did this, it was 8.2 centimeter. So according to the scale, 1 centimeter means 0.1 Newton, 8.2 centimeter mean how much? It will be 0.82 Newton. So the magnitude of this force is 0.82 Newton. Then we have to tell what is the direction without it. So I am going to measure this angle, and with the help of the protractor, I have measured this angle, and this angle is 62 degrees. So 62 degrees below your horizontal force. So this is the marking scheme. If you want to take more time with this marking scheme, please pause the video and take your time with this. So this is how this is done. Let me reduce the size so you can see the whole of this thing together. So this is the question which we have attempted. I hope you will be able to do this. And then this question is finished. Okay, so we have done question number 3 from this paper. And this question was basically related with the impulse, momentum, and the resultant force. Hopefully, you have understood this. I've tried my best to explain you these concepts. Please subscribe to my channel. Please share the link of this video. Please like this video. Share the link of this video with your class fellows, with your junior students, with your teachers, and share the link of this video on your WhatsApp groups, on your Facebook, on your TikTok, on your Instagram, on your X. Because you see, when you do this, you actually support me. And your support is very important. Special thanks to all the students in Pakistan, especially students in different cities of the Pakistan like Karachi, Islamabad, Lahore, Quetta, Faisalabad, Sialkot, Sargodha, where I also live, and especially students from Bangladesh, students from India, and students from Mauritius, and students from Saudi Arabia, students from uh, Dubai, UAE. So everyone all around the world, wherever you are, whether you are in the Singapore or you are in London, thank you very much for taking our time watching these videos and preparing your upcoming exam through my channel. It's a great blessing for me, and it's a great blessing for the students also. Thank you very much. Have a good day. God bless you all.